Hello everyone, in this video we'll discuss about performance analysis of an algorithm. First of all, what is performance analysis of an algorithm? If we want to go from city A to city B, then there will be many ways of doing this. We can go by flight, by bus, by train, and also by bicycle. Depending on the availability and convenience, we choose the one which suits us. Similarly, in computer science, there are multiple algorithms to solve a problem. When we have more than one algorithm to solve a problem, we need to select the best one. Performance analysis helps us to select the best algorithm from multiple algorithms to solve a problem. When there are multiple alternatives algorithms to solve a problem, we analyze them and pick the one which is best suitable for our requirement. The definition for performance analysis is that performance of an algorithm means predicting the resources which are required to an algorithm to perform its task. The performance of an algorithm depends on the following element. First one is whether that algorithm is providing the exact solution for the problem. Second one is whether it is easy to understand. The third is whether it is easy to implement. And the fourth one is how much space, that is memory, it required to solve the problem. And the fifth step is how much time it takes to solve the problem. Based on this analysis, performance analysis of an algorithm is performed by using following measure. The first is space complexity and second one is time complexity. Space complexity means space required to complete the task of that particular algorithm. It includes program space and data space. And the time complexity means the time required to complete the task of that algorithm. Then next is what is space complexity? When we design an algorithm to solve a problem, it needs some computer memory to complete its execution. For any algorithm, memory is required for the purpose like to store program instructions, to store constant values, to store variable names, and for few other things like function calls, jumping statements. The space complexity of algorithm means the total amount of computer memory required by an algorithm to complete its execution. When a program is under execution, it uses the computer memory for three reasons: instruction space, environmental stack, and data space. Instruction space, that is the amount of memory used to store compiled versions of instructions, and the environmental stack, it's the amount of memory used to store information of partially executed functions at the time of function call. Data space, it's the amount of memory used to store all the variables and constants used in the algorithm. Calculate the space complexity, we must know the memory required to store different data types, values according to the compiler. For example, the C programming language compiler for integer, 2 bytes to store integer value, 4 bytes to store floating type values, and 1 byte for character values, and 6 or 8 bytes for double. Let's see the examples of space complexity. How to compute space complexity? This code requires 2 bytes of memory to store variable a because a is a variable of integer type. An integer takes 2 bytes of memory, and another 2 bytes of memory is used for return value. Return type is int, integer takes 2 bytes. That means totally it requires 4 bytes of memory to complete its execution. And this 4 bytes of memory is fixed for any input value of A. The space complexity is said to be constant space complexity. If any algorithm requires a fixed amount of space for all input values, then that space complexity is said to be constant space complexity. Let's see the another example of space complexity. N into 2 bytes of memory to store array variable A. 2 bytes of memory for integer parameter n, and 4 bytes of memory for local integer variable sum and I. Sum takes 2 bytes and I is also takes 2 bytes, both the variables of integer type. And 2 bytes of memory for return value. That means totally it requires 2n plus 8 bytes. That means totally it required 2n plus 8 bytes of memory to complete its execution. Here the total amount of memory required depend on the value of n. As n value increases, the space required also increases proportionally. This type of space complexity is also known as linear space complexity. If the amount of space required by an algorithm is increased with the increase of input value, then that space complexity is said to be linear space complexity. Next is time complexity. Every algorithm requires some amount of computer time to execute its instruction to perform the task, and this computer time required is called time complexity. The time complexity of an algorithm is the total amount of time required by an algorithm to complete its execution. Generally, the running time of an algorithm depend upon whether it is running on a single processor machine or multi-processor machine. Read and write speed of the machine, the amount of time required by an algorithm to perform arithmetic operators, logical operators, return value, and assignment operators. Calculating time complexity of an algorithm based on the system configuration is very difficult task because the configuration changes from one system to another system. To solve this problem, we must assume a model machine with a specific configuration so that we can able to calculate generalized time complexity according to that model machine. To calculate the time complexity of an algorithm, we need to define a model machine. Let's assume that the machine configuration is single processor routine, single processor machine, 32-bit operating system, and it performs sequential execution. It requires 1 unit of time for arithmetic and logical operations. It requires 1 unit of time for assignment and return value. And it also requires 1 unit of time for read and write operation. Now we calculate the complexity of this example. First of all, int sum, int a comma int b, and sum is the function that return a plus b. This code require 1 unit of time to calculate a plus b and 1 unit of time to return the value. That means totally it takes 2 units of time to complete its execution, and it does not change based on the input value of a and b. That means for all input values it requires the same amount of time, that is 2 units. If any program require a fixed amount of time for all the input value, then its time complexity is said to be constant time complexity. Now in this case, fixed amount of time is there for all the inputs. That's why the time complexity is constant time complexity. Let's see the real life example of time complexity. Imagine a classroom of 100 students in which you give your pen to one person. You have to find that pen without knowing to whom you give it. Here are some ways to find the pen and what the O order is. Big O of n square. You go and ask the first person in the class if he has the pen. Also, you ask this person about the other 99 people in the classroom if they have that pen, and so on. This is what we call big O of n square. And the big O of n means going and asking each student individually. That is big O of n. And big O of log n, now I divide the class into two groups, then ask, is it on the left side or the right side of the classroom? Then I take that group and divide it into two and ask again, and so on. Repeat the process till you are left with one student who has your pen. This is what you mean by big O of log n. Big O of n square. Search if only one student know on which student the pen is hidden. Let's see some programming examples of time complexity. After the execution of this code, hello world is printed only once on the screen. So the time complexity is constant, big O of 1. That is, every time a constant amount of time is required to execute this code, no matter which operating system or which machine configuration you are using. Now after the execution of this code, hello is printed only n times on the screen. As the value of n can change, so the time complexity is linear, that is big O of n. This for loop is to be executed n times. That is, every time a linear amount of time is required to execute the code. This is all about performance analysis, time and space complexity of an algorithm.